What's up, data pipeliners? This is Data Engineer 1. Welcome back to another episode on Let's Write Pipes. In the last video, we were taking a look at how we can break down the requests object into a custom data set to put into our pipeline. In today's video, what we're going to be doing is we're going to be breaking down each of the different portions of the notebook to create the nodes for our pipeline. In this specific case, we're going to be going ahead with the graphing functions and creating graphing nodes for our pipeline. Okay, great. So let's continue onward. What's the next step that we want to do? Well, we have this kind of like this data assertions where we do some very quick column analysis. We can go ahead and skip that for now. I think this is very straightforward. I think we're most interested in looking at how we can generate these graphs. So again, Kedro comes with the matplotlib data set. So they have that built in. In order to make sure that you have it, you just have to, I think, do pip install Kedro, and then you put matplotlib right inside of square brackets. And this gives us access to the matplotlib, and it looks like we already have it installed, which is good news for us. So let's go ahead and try using that data set. First, what we're going to do is we're just going to clean up our pipeline. I'm going to get rid of our pipelines and nodes modules. And what I want to do instead is just have a simple pipelines Python file and then nodes Python file. And this is just personal preference. I like having them not as modules, but rather just as plain Python files for these tutorials. But there definitely is a case where you want to separate your pipelines and your nodes for testing and modularity purposes. Okay, so in this case, what we're going to do is we're going to start to generate this graphing data. The first part here is we have our very simple country values. So these are the countries where this particular data set with this particular scientific name is being generated. What we have here, we can just go ahead and say this node is very simple. It's going to be get country plot, like that. What it's going to do is it's going to take in a data frame, which is going to be our species data of data frame type. And then it's going to output a figure type. And so this figure actually comes from the matplotlib figures. So that's matplotlib figure, import figure. And so that's because what we're going to be using is we're going to be using, of course, our matplotlib figure diagram. So here we have our data frame. What we're going to do is we're going to pull out the country, and basically we're just copying what's going on here in this notebook. Value counts.plot.bar, which is, of course, bar horizontal. One little wrinkle here is that when you do the plot.bar, what it does is actually returns an axis subplot. So it actually doesn't return a figure. In order to grab the figure from this particular matplotlib, what you want to do is you want to do .get figure. And you have to add that little extra bit to make sure that you're returning a figure that is supported by the matplotlib writer. And that's the one that we're going to be using. So now we have this done, very simple. What we're going to do is we're just going to go ahead and add that to the pipeline. We'll have a pipeline here. This will just be our default pipeline for now. And then what we'll do is we'll refactor it in just a moment. So we're going to have node, going to import this name, it's going to be a Kedro node, and then we're going to use our function get country plot. And what's the data that we're going to be using? The data that we're going to be using is our brand new catalog right here, the GBIF request data set. In order to use it, we of course have to add it in to our catalog YAML files. Let's go ahead into catalog YAML and then add this guy in. So what we're going to do is we're just going to call it the GBIF dataset with our type being our bnhm.io.gbif quest dataset. And then the parameter, of course, is our scientific name. So remember, this is what we put in to the init arguments here, the scientific name, and that's what's going to get passed into the data set when we put it right here inside of our catalog. So the scientific name is one that we can pick out, and we can also just, of course, use our very simple argioids. Probably someone has to tell me how to properly pronounce that. So here we go. So now we have the scientific name, we have the type GBIF. We just go into the pipeline, and our input will now be GBIF. And then the outputs is going to be our matplotlib. We're going to actually go ahead and just say country plot. So it's actually matplotlib writer. There's no data set at the end of that. When we run this guy, we should have no problem. It's going to load from GBIF. It's going to grab the data frame. And then what it's going to do is it's going to run it through our get country plot and then output it into our matplotlib writer. But inside of our /data /o1raw country.png, and look at that, it looks almost exactly the same as our own plot here below me. Now, what is the difference between these plots? The difference is that we did not set seaborn. So there's a plot style. Now, this is something that you probably do have a preference for, where you want to actually set the style for your plot. So in order to guarantee that we have our style properly set, we can actually, I believe, just put the style inside of this folder here. I'm sorry, inside of this module. So we can just import from matplotlib, pyplot as plt. Then we can set that plot style right here inside of our run.py. And now when we rerun this guy, and here it's got the update. And again, that's because we changed that plot style within the run.py. So that's the easiest way to set your global variables. You could just put it inside of your run.py, and you have more familiarity. I mean, you know where to find those global variables. This is much better than if we were to set it in like a random node. Then people looking at your pipeline later on might not be able to find that particular setting. Continuing forward, now what we want to do is we want to go ahead and generate all of the rest of these. But of course, that's a little bit tedious to go through into the catalog, write in, okay, well, now we have the country plot. Now we want to have our basis of record plot, et cetera, et cetera. This is a little bit troublesome. So what you can do instead is use Kedro Wings. And the Kedro Wings documentation gives you an example of how we can do this. What we're going to do is we're going to override the default Kedro Wing configuration for a .png, right, which is normally a pillow image dataset. What we're going to do is we're going to override the .png to be of type matplotlib writer. And that'll make it much easier for us to generate the different plots that we need. So if we go back into our run.py, let's go ahead and install Kedro Wings right here. So we have hooks is equal to Hedgerow wings, import Kedro Wings, and then we also make sure you put the comma there because it's a tuple, and then we just go ahead and add in these dataset configs. And so we have some default dataset configs, which are listed there, obviously, but we're going to add in our extra one, which is the .png, with the type equal to our matplotlib writer. And so now, for any Kedro Wing configured data set inside of an input or an output, it'll use this matplotlib writer instead. So this is just a very convenient way to do this. And so now what we can do is we can actually go back into our catalog, remove these guys, and we should be able to generate the same country plot by just modifying the name inside of here. So we have our inputs being GBIF, and the outputs being, instead of country plot, we want to say 01 raw country plot.png. It's going to change the name. We're going to have a country plot.png rather than country.png. But the purpose of that is to show that this actually does work. And I think the next step here, as you can see with the GBIF, it is starting to take kind of a bit of time to wait for every single request from this scientific data. So what we can do instead is we can start to cache that data. But first, here, our country plot.png exists, and we have not modified anything inside of the catalog except remove our country.png data set. So now, of course, this makes it so much easier to begin generating the rest of these nodes. So I'm going to go ahead and do that now. And that job, very simple, is just going to be a copy paste job for each of these nodes. Now we've copied all of the different plots that are available inside of our Jupyter Notebook. And I want to point out something here, is that our country plot, the county plot, basis of record plot, and the get collections code plot, all of these plots are actually the same plot. We're doing a simple value counts, and then we're doing a horizontal bar graph on those value counts. You know what this means? The only difference between these guys is the column name. So here's something that you can do. Rather than have this like column name be the only difference between these different functions, you can instead have a generator function that'll generate these kinds of bar horizontal plots for you. So let me show you what that looks like. We're going to be calling this the generate value count bar h function. And what you're going to be doing is we're going to be passing in the target column that we want to generate the plot for. And then we create this inner value counter, right? Value count plot. And then that will be the one to take in the data frame, which will return the figure. And then so what you can do is you can just take this line here, and instead of redoing it on the country, you just do this on the target column. And then based on the target column, we return get value count plot. So what's going to happen is we're going to be able to return the function that has the curried argument of target column. And this way, we actually save on a huge amount of code. We can delete all of these pieces of code and then just use the different column names inside of the actual function call. Once we get rid of those, what we can go do is inside of the pipeline, since country plot no longer exists, we want to instead generate the value count bar horizontal. And then here is where we type in our country. By reusing this same function, we're able to generate all of these different get value plots. And so this is a very useful trick that you can employ when you generate your own pipelines in Kedro. One thing that I want to note here is, for starters, this inputs takes a long time. We've noticed, right? If we're going to run this pipeline, we're going to have to wait for every single one of these GBIFs to run, and that's kind of a waste of our time, I think. You should always be looking at how you can speed up your pipeline, optimizing your pipeline, because the faster your pipeline runs, the quicker you're going to be able to do more science and iteration. So in our case, what we're going to be doing is we're going to be separating the pipeline into two parts. We're going to be separating it into the load data, or you can even say the DE pipeline is the data engineering pipeline. And what this is going to do is it's going to download the data from our GBIF, and then it's going to output it into our raw folder as our species data. So this is going to be GBIF species data dot CSV. And the node here is actually going to be a Lambda node. It's going to be XX. It's going to be the identity function. And so what's going to happen is we're going to download the data from GBIF into that GBIF species data.csv. And then we can call that species.data.csv within all the other nodes. We don't have to make a catalog entry again because we're using Kedro wings. So this works straightforward as we've written it. Now that that's written there, the next part here is to update all these other GBIFs. And this is going to speed up the pipeline immensely. So let's go ahead and give the DE pipeline a run. And we can do that by modifying our run configuration here. Right now we're only doing run, but we can do pipeline DE. And we'll just duplicate this guy, Kedro run. And then we'll remove that pipeline DE here. And we want to do Kedro run, and then this one will be called Kedro run DE. Let's go ahead and run that DE pipeline. We're going to download from GBIF and then load it into the GBIF species. And of course, because we modified that original function, I forgot to remove it from the import. So we'll go ahead and run Kedro run DE. Oh, and it looks like that the pipeline nodes don't have unique names. So let's go ahead and just generate a few names very quickly. And so what I've done here is instead used very simple list comprehension, where we are pulling from this list of columns and then generating nodes based on that list of columns, since we're using the same function, the same inputs, and then slightly different outputs. And I believe actually the reason earlier for Kedro complaining about nodes having similar names is because we were reusing the same function input and then the same input and then the same output. So that was actually an error on my part. Forgot to change the outputs here. Since we were only supposed to be running the DE pipeline, thought it wouldn't matter, but it does because of the Kedro checks in place, and that's okay. So we're going to go ahead and just change the names. And so again, because we are using Kedro wings, we get away with this kind of easy pipeline writing. Otherwise, we would have to go into our catalog and then manually add in every single one of these output data sets as catalog entries inside of our catalog. So again, Kedro wings just makes it a little bit easier for us. Okay, so now that the default pipeline is fixed, we can go ahead and run the DE pipeline, and this should generate our DE data inside of the raw folder here. And that'll be named as GBIF species data.csv. Once that's generated, we can run the default pipeline and then pull that in to do all of our plotting. And so here's the moment of truth. Let's go ahead and switch this to Kedro run so we can run the default pipeline. We hit the run button and we'll see if we run into any errors. It looks like we do have one error, and that's this one right here, which is the GBIF species data is not existed inside of the catalog. And that's because our inputs here does not include the .csv. So that was a mistake on my part there. We run this guy one more time. There it goes. The whole pipeline is running, and we should be able to see inside of our O3 primary all of our plots. And let's go ahead and see if we can match them with the plots that we have below. Here's our basis of record by collection code. Then we have our basis of record plot here, which is, oh, it's supposed to be this one. Seems like this is a little bit erroneous. But we do have our collection code value, which is over here. Yeah, this is this one. And then we have our country value, which also seems to be a little bit mistaken, but our country value plot looks okay. I'm sorry, the county value plot looks also a little bit broken. We're going to have to check up and make sure that we have our names correct. But overall, it seems that the issue could be because of the way that the plots are being generated. It seems that Kedro is not releasing the subplot itself. So maybe let me just take a look at this really quick and debug for a moment. So the reason why the plots are messed up is actually very simple. This was a bit of an oversight and mistake on my part. What happened here was inside of the nodes, what we were doing was we were returning the figure, but not resetting the plot. And the plot is actually a global variable, obviously because we set the style when we're in the run.py. It just slipped my understanding here. So all we need to do to fix this is just grab the figure variable and then also import the matplotlib.pyplotplot, and then obviously just close that plot. So we actually have to do that for every single function where we're returning the figure. And so thankfully, because we were able to use that generate value count bar h, it's very easy to fix that one. And then we just have to fix the other two here. So what we do is we grab the figure, we close the plotting, the global plot value, and then we return the figure. And now when we rerun the pipeline, it actually works as expected. The proper plots are generated here. We have our basis of record, values, collection codes, value, county, country, and elevation. And those actually perfectly match up with the ones that we have here. So the next part of this, we can get into the mapping. I honestly think that this video has run over a little bit of time. Why don't we save that for the next episode on Let's Write Pipes? I hope you guys enjoyed and learned something today, and I'll see you guys in the next video. Take care. Bye-bye.